Welcome to The Explainer. So, who actually built the AI that's changing our world? Today, we're diving into the story of the modern AI era by looking at two of its most important architects, Jeff Dean and Noam Shazeer. Their work at Google did more than just create products, it literally forged the tools and the thinking that made today's AI revolution possible.
You know, this quote from Noam Shazeer really says it all. He's talking about his mentor, Jeff Dean, and this relationship, this partnership, is what ended up shaping so much of the future of computing. It's a story that goes way beyond just programming.
All right, so to really get a handle on where AI is today, we've got to rewind the clock. We're going back to a time before this whole AI boom, to when the actual bedrock for this entire field was being poured.
So picture this, it's 2007, long before any of today's chatbots. The machine translation team at Google builds this absolutely massive language model for a competition, and they win. I mean, they completely crush it. But there was one tiny problem. The system was so clunky, so impractical, that it took 12 hours to translate one sentence.
I mean, the scale they were dealing with was just wild. The model was trained on 2 trillion tokens. You can think of that as 2 trillion words and word fragments from all over the internet. At the time, trying to process that much data for one task was, well, it was basically unheard of.
So even though this model was powerful, it was totally useless in the real world. Now, when Jeff Dean heard it was taking 12 hours because it had to read from a super slow disk 100,000 times for one sentence, he jumped in. He spent a couple of months completely redesigning it so it could work inside the computer's super fast memory, and the result? The time went from 12 hours down to just 100 milliseconds. That one optimization became legendary, and really, it made large-scale AI practical for the first time.
Okay, so that early stuff proved that scale was everything. But to really set off the AI explosion, we needed a new insight, a really fundamental shift in how we think about the connection between our software and the hardware it runs on. And here was the key idea. Algorithms follow hardware. See, for a lot of AI tasks, you don't need the kind of perfect, high-precision math you'd use to, say, land a rover on Mars. If you're just trying to figure out if there's a cat in a photo, good enough math is totally fine. And that realization created this huge opportunity, because using less precise math means you can cram way more computing power onto a single chip.
And this kicked off this incredible feedback loop. It starts with the insight, right? Neural networks are basically just a ton of simple math. That leads to new hardware. Google starts building its own custom chips, TPUs, that are absolute monsters at doing that low-precision math. And once you've got that specialized hardware, well, now you can invent totally new algorithms like the transformer that are designed from the ground up to take advantage of it. It's this cycle where better hardware makes new software possible, which then creates demand for even better hardware.
So how did they know this was the right path? Well, the proof was just amazing. The early Google Brain team took a huge neural network and just fed it 10 million random frames from YouTube videos. They didn't label anything, didn't give it any clues, and what happened? The model, all by itself, developed what they called a cat neuron, a single tiny part of the AI that learned to activate only when it saw a cat.
Think about that. It was never taught the concept of a cat. It just figured it out from the raw data. This was a huge moment. It was definitive proof that the way forward was to just scale everything up, make the models bigger, and build the custom hardware to run them. And if you did that, these incredible, almost magical abilities would just emerge.
So that feedback loop, that's pretty much defined the last decade of AI. But now, Dean and Shazeer think we're right on the edge of the next big shift, moving past these huge static models we build today. I mean, think about how we make AI right now. We take a mountain of data, spend a ridiculous amount of money on computing power, and train one giant model from scratch. And if you want to make it better, you basically have to start all over again. It's slow. It's so expensive. But what if there's a better way, a more biological way? Their new vision is a move away from these monolithic models to what they call organic models. So instead of one single, unchanging piece of software, imagine an AI that's more like a living system. It can learn all the time, it has different parts that specialize in different things, and you can upgrade one piece of it without having to rebuild the whole thing from the ground up.
And this organic idea could completely change the game. Just imagine, you could have one team in London working on making the model better at understanding Southeast Asian languages, while another team in California is improving its coding abilities. And they could each just plug in their new, improved modules without messing with the whole system. Progress would get so much faster, so much more efficient, because hundreds of teams could all be making it better at the same time.
So you take this new vision for organic AI and you combine it with the trends that are already happening, and it points to a future that might be coming at us way, way faster than any of us are ready for.
We're now heading into what might be the ultimate feedback loop, where AI actually starts to speed up its own development. You can use AI systems to test out new algorithms way faster than humans can. And at the same time, we're using AI to design the very computer chips that AI runs on. You get this powerful cycle where every piece of the puzzle makes all the other pieces better and faster.
And look, this isn't some far-off science fiction. Jeff Dean is talking about using AI to take the chip design process from a year and a half down to just a few weeks. That means the actual hardware powering AI could be evolving in months, not years, and it could be perfectly customized for the new software that's being created right alongside it. The pace of progress here is just hard to wrap your head around.
So this self-reinforcing cycle brings up a really deep question. If AI can actually speed up its own invention, are any of us really prepared for the rate of change that's coming? The big takeaway here is this. The same architects who designed the first AI revolution, they're already busy building the next one. And as their journey shows us, the future isn't just arriving, it's accelerating.